Problem. I'll be doing problem 66. 66 reads, four passengers with combined mass 250 kilograms can press the springs of a car with worn out shock absorbers by 4 centimeters when they get in. Model the car and passengers as a single body on a single ideal spring. If the loaded car has a period of vibration of 1.92 seconds, what is the period of vibration of the empty car? So we don't know the mass of the car without the we don't know the mass of the car at all. So we want to find that out. And to do that, we have to know the spring constant. So first we find the spring constant by using this equation of force divided by distance, which is mg divided by x. So their mass is 250 kilograms and the force of gravity is 9.8 meters per second. And the distance that they compressed the car was 4 centimeters, which is 0.404 meters. So we do 250 times 9.8 over 0.04, and we get 61,250 newtons per meter for K. So erase this and put our new answer, 61,250 newtons per meter. So then we use the period equation to find mass, the mass of the car. So we know that omega equals the square root of k over m. So we use that in the period equation. So period equals 2 pi over omega, and period equals 2 pi over square root of k over m. Then we square both sides. We get t squared equals 4 pi squared over k over m. Then we multiply the mass up here, and we know that the period is 1.92 seconds. It tells us that. So 1.92 squared times m equals 4 pi squared. We also know k, so we plug that in. 61,250. So we get 3.69 m equals now actually the mass would come up here since it's over k on the bottom here, so the mass would just come up to here. So we have 3.69 equals 4 pi squared m over 61,250. Multiply both sides by 61,250. And we get 226,012 equals 39.48 times mass. So we divide by 39.48, and we get mass. The mass of the car with the passengers is 5,724 kilograms. So then we just subtract this by the passenger's mass to get the mass of the empty car, which equals 5,474 kilograms. So then we just use the period equation. We can find what omega is with just the car. So we do omega equals square root of k over m, which is, in this case, 61,250 divided by 5,474, square root of that, which equals 3.345. And so we just use the period equation. Pi over omega. In this case, 2 pi over 3.345. And 2 pi over 3.345 equals 1.88 seconds. So that is problem 66.